Along Indonesia's coastlines, life moves with a calm rhythm, shaped by the sea. Markets open at sunrise, fishing boats drift across quiet water, and millions begin their day unaware of the force building beneath them. Deep under the Indian Ocean, one of the most powerful geological systems on Earth is showing signs that it may be preparing for something significant. This is the Sunda Megathrust, the same fault that unleashed the 2004 earthquake and tsunami, one of the deadliest disasters in modern history. Today, scientists are watching it closely because several sections have fallen unnaturally silent. Not the silence of stability, but the tense stillness of a compressed spring refusing to move. Along the western coasts of Sumatra and Java, entire portions of the megathrust have not released major energy in centuries. These locked segments continue to absorb pressure as the Indian-Australian plate pushes beneath the Eurasian plate, dragging the crust westward. GPS sensors on shorelines and the seafloor detect this steady deformation. Minute shifts that no human would notice, but instruments record constantly. A silent struggle between plates that can only continue for so long. To understand why these quiet zones matter, we have to return to the moment the world witnessed the full power of this fault. In 2004, a massive portion of the Sunda Megathrust ruptured, producing a magnitude 9.1 earthquake that lifted the seafloor by several meters. The displaced water raced outward as a tsunami that killed more than 23,000 people across 14 countries. But even an event of that scale did not release all the accumulated tension. The 2004 rupture affected mainly the northern section. The central and southern portions, including the Mentawai region, Nias Java, and the Sunda Strait, remain locked today. These are the segments drawing increasing scientific attention. One of the most concerning areas lies southwest of Sumatra, known as the Mentawai seismic gap. Geological evidence from coral uplift and coastal sediments reveals a repeating pattern. Roughly every 2 centuries, this segment ruptures violently. The last major events were in 1797 and 1833. Nearly 200 years later, the region is still silent. Coral microatolls subtly record ongoing deformation, sinking as the overriding plate is pulled downward. A clear sign that strain is building, not releasing. The amount of stored energy in the Mentawai Gap is comparable to what preceded the 2004 earthquake, which is why it is often described as one of the most dangerous seismic zones on Earth. Farther southeast, another silent stretch raises similar concern. The Java segment of the Sunda Megathrust has no well-documented record of producing a truly massive earthquake in modern history. For a subduction zone stretching thousands of kilometers, this absence is unusual. Studies show that parts of the plate boundary offshore Java are tightly locked. GPS networks and ocean bottom instruments detect steady strain as the crust above is dragged toward the trench. The stakes are enormous. Java is among the most densely populated islands in the world. Cities like Jakarta, Bandung, and Surabaya lie close enough that a major rupture offshore could produce intense shaking. Along the southern coast, tsunami arrival times could be measured in minutes. Across the entire length of the Sunda Megathrust, scientists see a consistent pattern of stress building along large portions of the fault. Much of the plate boundary behaves like 2 surfaces pressed tightly together, absorbing motion rather than releasing it. Along the edges of these locked zones, clusters of tiny earthquakes appear. Too small to be felt, but precise enough to outline the boundaries of the stuck segments. These microquakes are not dangerous on their own, but they reveal where pressure is accumulating. In some regions, the megathrust releases strain through slow, silent slips lasting days or weeks. These deep movements do not signal an imminent quake, but they show that lower parts of the fault are shifting while the shallow crust remains locked. This contrast is characteristic of subduction zones before major ruptures. Even the coastline reflects the tension. Some areas gradually sink as the crust bends downward while others rise. Coral reefs, GPS stations, and satellite measurements all confirm that the overriding plate is being warped as the megathrust continues to hold firm. If one of these segments finally gives way, the consequences will depend entirely on which section ruptures. A failure along the Mentawai segment would send powerful shaking across western Sumatra, followed by a tsunami that could reach the coast in as little as 10 to 20 minutes. The shape of the seafloor in that region allows waves to rise quickly, pushing water far inland. If the Java segment were to rupture instead, the shaking could threaten major urban centers directly, and towns along southern Java would have only minutes to react to any incoming wave. With such dense populations, even a brief delay in warnings could have devastating effects. In rare cases, neighboring segments can rupture together, generating earthquakes among the largest ever recorded. Scientists do not assume this will happen, but the Sunda Megathrust is long complex and capable of cascading failures, much like the event that struck Japan in 2011. None of this means a major rupture is imminent, but all of it reflects what the megathrust has done repeatedly throughout geological history. It stores energy quietly, then releases it suddenly. The purpose of studying these signals is not to create fear, but to understand a system that influences millions of lives. No scientist can predict the exact moment a megathrust earthquake will occur, and responsible researchers never claim one is imminent without clear evidence. Still, the indicators now observed tell a consistent story. Locked sections that have not slipped in centuries. Long periods of seismic silence. Slow bending of the crust. Microquakes tracing the fault's edges. Deep slipping events revealing motion the shallow crust cannot match. Together, they form a pattern seen in subduction zones that continue to accumulate strain. These features do not predict a specific timeline, but they show the forces shaping the region's future. Since 2004, Indonesia has built one of the most advanced tsunami early warning systems in the world. Buoys, seafloor pressure sensors, GPS deformation networks, and real-time seismic monitoring all work together to detect sudden shifts along the megathrust. Technology cannot prevent an earthquake, but it can provide crucial seconds, sometimes minutes, for people to reach safety. Just as important are the human systems. Across vulnerable regions of Sumatra and Java, schools and villages conduct regular evacuation drills. Children learn exactly where to run when alarms sound and how to reach higher ground without hesitation. In many communities, these drills have reduced evacuation times to mere minutes. A critical difference in places where tsunami travel times are so short. Indonesia's coastline is vast and complex, but communities have shown remarkable resilience, building awareness and preparedness that did not exist before 2004. So is the Sunda Megathrust preparing for another massive event. The truth is that no one can say when a rupture will occur, but scientists can say with confidence that stress is still building, that several major segments remain locked, and that the crust above them continues to deform under pressure. These signals do not give a date or a countdown, but they confirm that the forces behind the 2004 disaster are still active, still accumulating energy, and still shaping the region. Whether the next major event happens tomorrow or generations from now, the Sunda Megathrust remains one of the most powerful natural systems on Earth, and one of the most closely studied. The silence beneath the Indian Ocean is not a sign of peace. It is the sound of pressure building slowly and inevitably. But knowledge transforms that silence into understanding, and understanding becomes preparation. Awareness does not eliminate risk. It reduces vulnerability. And in a region where minutes can define survival, that awareness can make all the difference. Which segment do you think poses the greatest threat, Mentawai Java or the Sunda Strait? Share your thoughts below. I am reading every comment.